Algebra II Precalculus. As a precalculus, the convention is to teach sequence and series, infinite series, and we just follow that. I think it's good to introduce the concept of infinity. In the beginning of calculus, we talk about new number system, the infinitesimally small number, and that concept is definitely necessary. But here we just simply introduce the concept of infinity using sequence and series. Okay. What is a sequence? The sequence is a series. Actually, it's a number showing up with some rules. For example, 1, 1.1, 1.11, 1.11, so and so, or 0.9, 0.99, 0.999. And question is, if you keep repeating same sequence using the fixed rule, what's the ultimate number you're going to see? For example, this one is 1.1111. It's like 10 over 9. Okay, cyclic number, so 10 over 9. 0.9999 also 1. Diverging sequence 2, 4, 6, 8, 10, 12, and ultimately it goes infinite. If it's reducing, well, then it's going to negative infinity, because eventually it goes 0. This reducing here, this one, and negative 0.1, 0.2, so on so. Alternating sequence 1, negative 1, 1, negative 1. This alternating sign. How about 1, 0, 5, 1, 0.25. This is 0.5, 1, 0.25, 1, 0.125. This side is decreasing. Probably it goes 0, but 1 is showing up all the time. So alternating final number. So there are many types of sequence. The create a sequence by summation. Okay, so actually, if you keep repeating 0.1111 all the way, this is the same as adding 0.1, 0.01, 0.001, so on so. Means 1 over 10 to the nth, and n is from 1 to n, and we are making this n infinitely large to get the ultimate number. So this is same as this. It's just a short form using summation, right? And n is 1, 2, just a little bit more mathematical instead of expanding the number like that. And n equals infinity, this ultimate number. There is ultimate number. One over 9 actually, right? So this kind of addition is called series. You're adding number, and when n goes infinity, summation is a series. It may converge. This is an example of converging. Diverge. Well, when you add a number, it may go, the summation means the sum of all the number could be infinite, or alternate. Or when n goes to infinity, that's the infinite series we call, when n is go infinite. Okay, so you're just practicing how to describe the number sequence, and number sequence is equivalent to the series. Okay, let's look at the summation formula. Okay, when you add a bunch of number by some rule, so what will be the summation total value? Okay, there are some simple cases we can make a formula, and we can use this formula to quickly calculate. For example, summation c is a constant, some number, say c is 2 and n is 5, m is 1 in this case. So what's happened is the I equals m 1, then 5 minus 1 plus 1, this is 5, right? So summation will look like 2 plus 2 plus 2 plus 2 plus 2. This summation value is given by this. 5 minus 1 plus 1 is 5. 2 times 5. Very simple, right? Formula 2. Prove the formula 2 below. Okay, let's see. Formula 2 is summation I 1 to 5, right? So it's going to be 1 plus 2 plus 3 plus 4 plus 5. Okay, and that is given by n plus m is 6 times minus 4 plus 1 over 2. So 15. Is that correct? Let's examine. This is 5, 5, 10, 5, 15. Okay. So how do you prove this? This actually n minus 1 plus 1 is the number of times you're adding. And what's number you're adding? Since I is linearly increasing, you take average. What is average? N plus m over 2, which is this part. Okay, so you take average, multiply by number of summation. That's what it is. Now simplify. If we know m is 1 or 0, then formula is simplified to this. Okay, so that's the summation formula. Make a bar graph of n column study. Oh, this is how to prove this. Okay, you can stop the video and read it, but I already explained to you. You have a number of times you add, which is this, and which value take average. This and this give you average. Okay, so summation formula 2. A little bit more complicated case, I square. So if n is 5, that means I square gives you 1 square plus 2 square plus 3 square plus 4 square plus 5 square, and that is given by 5 plus 1, 2 times 5 plus 1 over 6. Okay, so this sometimes we use the I cube, plus 2 cube plus 3 cube plus is given by this formula. And this can be proved that if you spend some time on a paper and a pencil, take the paper and the pencil, stop the video, and prove these formulas. Okay, the proof is research project for you, and this is within the Algebra II. You will learn it in school. So here's the example: summation practice, and red one is answer. So using formula, you practice 1, 2, 3, and 4. Okay. So again, the practice is important. How to calculate the series. Now, this cyclic decimal number, probably you learned this already. The cyclic decimal number can be rational number, means the ratio of integer. Okay, so using cyclic, this is gonna be the review. You have learned this already before. If not, go through this. The red ink shows how to calculate it. Okay, so the basic general form is this one. So that's how you convert cyclic decimal number to integer. Now, infinite series. So when you add a number infinite times, there is a condition that series can converge for sure. That means a0 over an minus an. That means next term should be always smaller. Means number has to go smaller, smaller, smaller. Otherwise, it never converges. It's called infinite, right? Example is this way. But this is a necessary condition. Okay? It's not satisfactory condition. See, this is an example. It's getting smaller and smaller, but if you add them all, it goes infinite. Right? It has to be sufficiently getting smaller each time when you add it. So this is very important. When you look at the infinite series, you can see obviously the number has to be getting smaller. Okay, so this is just an introductory section for calculus. And if you finish geometry already, then you can move on to calculus video. If you haven't finished the geometry, you should go ahead and finish up the geometry before you go to calculus. Okay, I hope you enjoyed this video, and I'll see you in the next video.